This section is on independent probability. In this section, you will learn how to calculate the probability of a single event occurring, and you will learn how to calculate the probability of several independent events occurring. You already know that probability is a way of calculating how likely an event is to happen. But what is independent probability? Let's examine this by looking at some examples. Tossing a coin and rolling a die are examples of independent probabilities. When probabilities are independent, the outcome of one event does not affect the outcome of other events. The probability of tossing a coin and getting heads is 1/2. The coin does not know and is not influenced by what happened on previous tosses. If you toss a coin 9 times and it comes up heads all 9 times, the probability of getting a head on the 10th toss is still 1/2. Let's look at the probability formula. The probability of something happening, A, equals the number of ways an event can occur over the number of all possible outcomes. For example, what is the probability of rolling an even number on a die? Well, recall that a die has 6 faces and with the number of dots is 1, 2, 3, 4, 5, or 6. You can roll a 2, 4, or 6 on the die. Therefore, there are 3 ways of obtaining an even number. But there are 6 different outcomes of rolling a die. Therefore, the probability of rolling an even number is 3/6, which reduces to 1/2. Let's extend this idea. What is the probability of tossing a coin and getting tails while also rolling a die and getting a 5? The probability of tossing a coin and getting tails, which we will designate as P of t, equals 1/2, while the probability of rolling a die and getting a 5, P of 5, equals 1/6. Since tossing coins and rolling die are independent events, to find the probability of both events occurring, multiply the 2 probabilities together. 1/2 times 1/6 equals 1/12. Therefore, the probability of both tossing a coin and getting tails and rolling a die and getting 5 is 1/12. Basic concept. The sum of probabilities that completely describe all possible outcomes in a given situation is 1. When tossing a coin, there are only 2 possible outcomes, heads or tails. The probability of getting a head, which we call P of h, equals 1/2. The probability of getting a tail, P of t, equals 1/2 also. The sum of all probabilities of getting either a head or a tail is P of h plus P of t, which equals 1/2 plus 1/2, and that sums to 1. The same idea applies for throwing a die. The probability of rolling a 1 is 1/6, the probability of rolling a 2 is 1/6, the probability of rolling a 3 is 1/6, and so on. You add all of those 1/6 together for all 6 possible outcomes, and it sums to 1. Here's an example of how to use that fact to find the sums of probabilities. Suppose you have a jar filled with an unknown number of marbles. The marbles can be either red, blue, or green. Half of the marbles are blue, while 1/4 of the marbles are red. What is the probability of drawing a green marble? To find the answer, add the known probabilities and subtract that sum from 1. Look at the equation on the right of this slide. The probability of drawing a blue marble plus the probability of picking a red marble plus the probability of picking a green marble all equal 1. And the probability of getting a blue marble is 1/2. The probability of a red marble is 1/4. We can substitute into that equation. Recall that the probability of blue plus the probability of red equals 1/2 plus 1/4 equals 3/4. We can call the probability of getting a green marble x. Therefore, the probability of a blue plus the probability of a red is 3/4, plus the probability of green is x, and that sums to 1. If we subtract 3/4 from both sides, our answer becomes x equals 1 minus 3/4, or x equals 1/4. Therefore, your probability of drawing a green marble from the jar is 1/4. Let's use a diagram. A spinner is shown below. What is the probability of getting prime numbers on 2 successive spins? The prime numbers are 2, 3, 5, and 7. Recall that 1 is neither prime nor composite. There are 4 ways to get a prime number and 8 possible outcomes. The probability of getting a prime number on the first spin is 1/2. The probability of getting a prime number on the second spin is also 1/2. Because these are independent events, what happens with the spinner on the second spin is not influenced by what happened on the first spin. We multiply those two probabilities together. 1/2 times 1/2 equals 1/4. Now let's do some practice problems. And pause the video after each problem, work that problem, and then come back for the answer. Here's practice problem 1. Charlie is doing card tricks with a standard deck of cards. What is the probability that he will draw the ace of clubs? Here's the answer to practice problem 1. It's 1/52. Recall that we're using the probability formula, and we're making a ratio of the number of ways of drawing an ace of clubs over the total number of ways of drawing a card. Well, there's only one ace of club in the deck, therefore there's only one way to get it. And the total number of cards in the deck is 52. Therefore, the probability is 1/52. Practice problem 2. What is the probability that Charlie will draw a diamond from a 52 card deck? The answer to practice problem 2 is 1/4. Note that there are 13 cards in a deck that are diamonds. Therefore, the number of ways of drawing a diamond is 13. The total number of ways of drawing any card is 52. 13 over 52 reduces to 1/4. Practice problem 3. A couple plans to have 3 children. Assume that the probability of having a boy is equal to the probability of having a girl, and that each probability equals 1/2. What is the probability of the couple having a girl followed by 2 boys? The answer to practice problem 3 is 1/8. The probability of having a girl first is 1/2. The probability of having a boy second is 1/2. The probability of having a boy third is 1/2. We multiply all of those probabilities together because they're independent. That's 1/2 times 1/2 times 1/2, which is 1/8. Practice problem 4. What is the probability of rolling an even number on a die followed by drawing the jack of hearts? The answer is 1/104. To find the answer, multiply the probability of rolling an even number on a die by the probability of drawing the jack of hearts. Rolling an even number on a die has a probability of 1/2. There are 3 even numbers, 6 possible outcomes. 3/6 reduces to 1/2. There is 1 jack of hearts in a 52 card deck. The probability of drawing a jack of hearts is 1/52. Multiply 1/2 times 1/52 for an answer of 1/104. Practice problem 5. A jar contains 3 types of candy: miniature bags of chocolate kisses, peppermints, and caramels. The odds of getting a chocolate kiss are 1/3. The odds of getting a peppermint are 1/4. What are the odds of getting a caramel? The answer is 5/12. Remember that you can subtract the sum of the known probabilities from 1. The sum of the known probabilities is 1/3 plus 1/4 equals 7/12. 1 minus 7/12 equals 5/12. A jar contains red, blue marbles and orange marbles. If the odds of getting a red marble are 3/4 and the odds of getting a blue marble are 1/8, what are the odds of drawing an orange marble? The answer is 1/8. Recall we can add the probabilities of 3/4 plus 1/8, and that becomes 7/8. 1 minus 7/8 equals 1/8.